How did the cosmos come into being? And how about this, if it's difficult to answer? Before our cosmos, what existed? Let's see what scientists have discovered thus far as they attempt to answer the most challenging topic in history. Thanks to Edwin Hubble, who one day on Mount Wilson in Southern California pointed his telescope at the sky and discovered that these sporadic clouds of gas flying everywhere are actually other galaxies, and there are many of them. We have solved this mystery in the 20th century. In addition, he discovered something else that permanently altered the course of history. They are in motion. So to answer your question, it basically meant that the cosmos is growing, and if it is expanding, it most likely had a beginning somewhere. At this point, all we need to do is reverse time to determine the start point. The Big Bang Theory is finally here, but it took the scientists several more years to develop it. Do you understand that nothing has ever been somewhere because neither where nor when existed? In reality though, there was only one thing. It was the so-called cosmic singularity, a highly hot, dense, and extremely small state of our universe. The pressure and temperature inside our universe would be tremendous if it were condensed into a tiny ball. It was eventually impossible to resist them, and then the Great Bang occurred. Everything we perceive now, including time and space, as well as fundamental physical forces, was the result of an explosion of matter and energy. Quarks were also strewn all over the place. All of these quarks, tiny particles that comprise our world, were simmering in a cosmic soup that was extremely hot. They were drawn to one another by gravity as it cooled. Just 12 to 14 billion years ago, they came together to form atoms, then molecules, and finally the world's first objects, stars. Okay, so we now know how the cosmos came into being, but what existed before then? American cosmologist and theoretical physicist Alan Harvey Guth has dedicated his life to unraveling this puzzle. Guth discovered various problems with the Big Bang Theory after learning about it. For instance, stuff was distributed quite evenly, which is not how it should have been. Let's place a white canvas on the floor and suspend a paint-filled balloon from the ceiling. The balloon will burst if it is dropped, leaving the canvas in complete disorder with a number of spots strewn around haphazardly. The two are not alike. However, the universe didn't actually appear like that. Let's draw a tiny red on the canvas rather than tossing a colored ball from the ceiling. We'll notice a circle progressively expanding in all directions as we continue to enlarge it and record it frame after frame. That's the truth. The early universe was proportionate and extremely even. That was the theory of inflation that Guth discovered. According to this theory, there was a force that could have produced a powerful acceleration prior to the Big Bang, and that could have instantaneously and uniformly distributed everything in space. The majority of scientists now rely on Guth's successful notion. This conception of the universe's creation is sufficient for the majority of them, but not for everyone. According to German physics professor Martin Bogewald, the universe was created very differently. Remember how we discussed the cosmic singularity? According to Martin's hypothesis, the universe couldn't suddenly collapse into a tiny, infinitely dense, and extremely hot state. This is absurd. Then again, where did it originate? Let's examine an antique clock's pendulum. The pendulum swings in both directions. It moves smoothly, continuously, and without interruption. We typically perceive time in this way. It never stops flowing. But hey, quantum time. That is not the case with quantum time. It resembles a clock's second hand more. It has brief pauses and is divided into small pieces. As with a clock's second hand, the start of one time segment always marks the conclusion of another. You see what I mean? Now let's return to balloons. The Big Bang Theory states that our universe used to grow and inflate like a balloon. However, it will eventually blow away. The universe will begin to contract and eventually reach cosmic singularity again. Then, you know what? The Big Bang as well. Nothing suddenly materializes and then vanishes. The hypothesis of the monster world holds that the end of one universe marks the beginning of another. Neither the earliest nor the last universe is ours. Before and after us, there were and will be millions of comparable universes. Despite its seeming rationality, this theory is far from comprehensive. Regretfully, we lack the information necessary to locate all of the supporting evidence. All of this is merely a theory at this time, although other people have even more bizarre ideas. Scientists spread such bizarre theories that no one could possibly come up with. South African physicist Neil Turok and his American theoretical physicist colleague Paul Steinhardt search for solutions that extend much beyond our cosmos. According to them, there have been and will continue to be an endless number of universes before ours. Not only will there be an unending number of Big Bangs, but we are all caught in a never-ending cycle of parallel world rebirths, and our universe is merely one among an infinite number of others. This sounds both amazing and terrifying. But how does it operate? This idea holds that our cosmos is housed inside a membrane that is referred to as a brain. To put it another way, we're trapped in an elastic surface that can stretch, compress, oscillate, and so on, much like cloth on a rope. The locations of these parallel universes are close to one another. Everybody has neighbors. We are not an anomaly. We cannot see another universe, even when it is only a few inches away. This is due to the fact that the fourth dimension is included in the minuscule distance that separates us. How do brain collisions create these universes? Slowly but surely, these brains are drawing nearer to one another until they eventually crash, producing two parallel universes and two huge booms. After that, they start to move apart. The worlds that were constructed are still alive. This is where we are at the moment. A new universe will emerge as a result of the brains colliding once more after they vanish. Do you recall the theory of inflation? The Big Bang was pushed and accelerated by an enigmatic force. Well, everything would make sense if we really collide with another universe. Naturally, all of the information presented here is greatly simplified. If string theory and M theory, two titans of quantum mechanics, are correct, they could explain nearly everything in our universe. However, the thought that our planet is only a piece of cloth on a robe sounds like total gibberish. The process of formulating a hypothesis is enormous. Numerous non-working hypotheses were swept away by Turok and Steinhardt's massive computations. They must also transcend the limitations of the human intellect and think simultaneously in 11 dimensions in order to solve this. Regretfully, this brilliant and bizarre concept was ridiculed. According to Turok and Steinhardt, scientists are just like everyone else. They also fear change and the unknown, and it's frightening to doubt everything we once thought was true. For example, many years ago, people didn't think the planet was round. The Big Bang Theory then infuriated them. Without anxiety and difficulty, we cannot produce discoveries. Turok and Steinhardt don't intend to give up so quickly because of this. Ultimately, the information we now possess only indicates that all three explanations are equally plausible. Therefore, at this point in human development, we may never know which answer is right. Unfortunately, we can only speculate as long as we lack proof. However, there is a chance that we will discover something that will finally open our eyes and answer the riddle of the origins of our world. That concludes today. So if your curiosity has been satisfied, please like and share the video with your friends.